Alright, so now let me give you this as the basic before we go to some past papers. So let's just say they tell you that we have got a 12-meter long wire. So let's just say you've got a 12-meter long wire and it is used to form a rectangle. And then they ask you to find the dimensions. So they ask you to find, let's just fix it. So they ask you to find the dimensions, right? Such that the area will be maximum. So here's what I want you to memorize. Whenever it comes to a 2D shape, right? Whenever you've got two unknowns, you need to have the equation for area and the equation of perimeter, right? So these are going to be important for some high levels. So perimeter. Whenever you've got two unknowns and it's a 3D shape instead, you need to know, you have to create the equation for surface area. So for surface area and the volume. So forgive my handwriting. So, right, when you have got a 2D shape with two unknown, area and perimeter, 3D shape, surface area and volume. So now let's look at this scenario. Whenever they tell you the length of something, immediately you indirectly have the perimeter, right? So in other words, we know that if we add this, and this, we should get 12 because perimeter is just adding all the sides together and the answer is the perimeter, right? So it means that when you add this, you get 12. Now notice this is a rectangle, so because it's a rectangle, we know this side is not equal to this side. So we can basically call this x and we can call this y. Right? So we can call it x and y. So we know that because it's a rectangle, this is equal to this and this is equal to this. Right? So notice the problem that we have is if we try to find, okay fine, I don't know why I wrote it like this, but if we try to find the area, the problem that we have is that we know the area of a rectangle is length times breadth, right? So now it means it's going to be x times y. So the problem with this is that we've got two unknowns. So how do we solve it? We need another equation for the perimeter, right? So let's create an equation for the perimeter. So if we create an equation of the perimeter, notice something. Notice that it's going to be perimeter is equals to x plus x, which is just 2x, right? So it's just going to be 2x plus 2y. Now, whenever you have the situation of two unknowns, you will always have the answer of one. For instance, if they ask for the perimeter to be maximum, they would have actually given you the area. But now they ask for the area to be maximum, so they will actually give you the perimeter, right? So it means 12 is the same as 2x plus 2y, because remember they told us a 12-meter long wire is formed into a rectangle. So it means that when you add all these sides together, it should be equal to 12, right? So it means that 12 is equal to 2x plus 2y. So you can leave it like this, or you can simplify it. Notice that if I divide everything by 2, I'm going to have 6 is equal to x plus y. So I hope you get it, right? So this is only for two unknowns, right? Most of the time you will actually have one unknown. But this is the situation where we've got two unknowns, right? So when we've got two unknowns, we're going to create the formula for area and the formula for perimeter. If it was a 3D shape, we would have come up with the formula for surface area and the formula for volume, right? So once you have this, the equation of the first one, sometimes they can even give you the first question that will say show that x is equals to something over y. They would have actually said show that x is equals to 6 minus y, for instance. That would have been the first question. But even if they did not ask you that question, if you see two unknowns, you already know that you have to make sure you have got two equations and use one of the equations to make something the subject of the formula. So for instance, here if we make x the subject of the formula, it means it's going to be 6 minus y, right? So sometimes you might have to create it yourself. Sometimes they can make it easier by asking you this question first, by saying show that show that x is equals to 6 minus y. Then you will remember that, oh, the second question is asking for maximum area, meaning that the first question wants the perimeter. So you create the equation for perimeter and then you just solve. Yeah, but it's not always that case, right? Sometimes it's something simple like maybe we have to use Pythagoras theorem and we'll be able to get one side in terms of the other. Yeah, so I'm talking about the situations where you see that you've got two unknowns, then you know it's going to be area and perimeter. So 3D shape, surface area and volume. All right, but we'll go through some past papers. I'll show you something. So notice that since we've made this the subject of formula, we can easily substitute it into the area formula. So we're going to say area is equals to, we have x, right? X is 6 minus y. And then we're going to have times y. Remember, it's xy, so xy, right? X is 6 minus y. So now let's multiply this. So we know that area is going to be equals to 6y minus y squared. So you can rearrange it. You can choose not to rearrange it. I just want to rearrange it because I want to show you something. Notice that this is actually a parabola, right? It's just that there's no c. So this is in the form of ax squared plus bx plus c, but where's this c0? So I'll explain why I'm showing you this. So notice that we can just say, let's call this ay because it's written in terms of y. Let's just call it like that. Even if you don't do this, you're still going to be fine. So now notice something, right? Whenever they ask for the maximum, how do you know you're on the right track? It's because if they ask for the maximum and it's a parabola, if it's a cubic graph, it doesn't matter. But if it's a parabola, notice that the value of a is negative. When it's negative, it's a frowny-face parabola. So negative frowny-face parabola, has got a maximum value, has got the highest value, right? But if it was a smiley-face parabola where the stuff is positive, right, it would have had the minimum. So they would have asked you for the minimum. So if they ask you for the minimum and then you see that this is negative, there is a problem. Or if they ask you for the maximum and this is positive, there is a problem, right? But for now, we know we're on the right track because they asked for the maximum and this is a front face parabola. So how do we get the maximum or the minimum value? Even if you didn't understand what I just said, how do we get the maximum or the minimum value? We always have to first get the first derivative, right? So when we get the first derivative, it's going to be equals to minus 2y plus 6. And then we always have to tell them the first derivative is equals to 0. There is a mark for that. So to get the maximum, whenever they ask for maximum or minimum or something, always get the first derivative and make it 0. So notice that, so that's what you'll do, right? Whenever they ask for the maximum or the minimum of something, right? You have to get the first derivative and you have to make it equals to 0. So now let's solve. So we've got 0 is equals to minus 2y plus 6. So now if we take that to the other side of the equation, we've got 2y is equals to 6. If we divide both sides by 2, we get y is equals to 3. So now we've got y as 3. So now we just need to get x because these are dimensions. Whenever they ask for dimensions, don't get confused by the question. It just means the sides. So like for instance, length and breadth, right? So we got y. Y was 3. So we just have to get x. So how do we get x? We have to use any one of the equations that has got x that we've created. For instance, this one has x, right? So notice that it's going to be 6 minus 3 because y was 3. So it means that x is also 3. Great. So it means x is 3. So we have found the dimensions that will result in the maximum area. So it means that this has to be 3 and this has to be 3. It means that for the area to be maximum, it has to be a square. Yeah. So now let me explain something. There's a difference between them asking you for the x value that causes the value to be maximum or the maximum value. Here they ask for the dimension that will result in a maximum. What if they ask for the maximum value? If they ask for the maximum value, you now have to go back to the original equation and get the actual maximum area. So notice that if we substitute that, you could substitute it here, right? Or you could even go back to the first one. Remember, we said area is equals to x times y. Any one of them will work. So remember, x was 3, y was 3, so it means the maximum area is 9. Even if we substitute it here instead, y is 3, right? So we'd get 6 minus 3, it's just going to be 3. And here it's just going to be 3. So notice the maximum area is still 9. So if they ask you for the dimensions that result in a maximum area, when you get the dimensions, you stop there. But if they ask for the maximum area, make sure you get the maximum area. So how do you avoid mistakes? Always refer back to the question and see if you have answered it. Then you want. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEP, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement. If you're interested in knowing the prices, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. Make a mistake by not answering the question fully. Alright, here is another question, also relatively easy before we go deeper. So now they said a soft drink has a volume of, so notice they give you the volume, right? So if they give you the volume, obviously they're going to ask for the minimum or maximum surface area. If they give you the surface area, they're going to ask for the minimum or maximum volume, right? This is a 3D shape. So they said a soft drink rather has, okay, fine, a soft drink can has a volume of 340 centimeter cube, a height of h and a radius of r. So the first problem that we have is that we've got two unknowns, right? So now they said express h in terms of r. So if they do that, if we've got two unknowns and they ask for h in terms of r, notice there is no easier thing, there is no right angle triangle and stuff that we can use, right? So the only thing that we can use is either volume or surface area. So whenever they give you an answer of something, you're definitely going to use it. So that's optimization. Every time they give you an answer of something, you know you're going to use it. So now, and by the way, they can choose not to ask these questions. They can choose to ask this immediately, right? If they ask this immediately, I'll show you something. Let's just solve this one before I'm going to show you that. So notice we've got two unknowns. So we know we're going to need both the surface area and the volume. So obviously, we're going to use the volume because they gave us the volume. So we know volume. So you have to know the volume. I'm going to summarize all the formulas by the end, and I'm going to show you which part comes from where, because it's very important, especially if they give you composite shapes, like if they put a semicircle in front. If you create the formula for surface area, it won't just be the surface area of the semisphere and the surface area of the cylinder. There is some parts that are going to be removed. So I'm going to show you that at the end. Okay, for now, let's just continue with this. So you have to know the volume of cylinder. So the volume of any prism, what is a prism? A prism is a shape with rectangles all over. For instance, this is a prism, right? A cylinder is also a prism because the whole thing at the side is actually a rectangle if you unfold it, right? So that's how it is. So yeah, even if we've got this, a triangular prism, it's a prism, right? So why am I showing you this? The volume of any prism is always area of the base times height. So the volume of any prism is area of the base, so area of the base times the height. So what is the area of a base in this case? Because the base is a circle, it's a circular prism in a way. So because the base is a circle, what is the area of a circle? The area of a circle is pi r squared, and then times the height. That is why the volume of a cylinder is pi r squared h, right? So the volume of any prism is area of the base times the height. The volume of a rectangular prism, for instance, is area of the base, which is a rectangle, right? So it's area of the base, which is length times breadth, times the height. So that is why the volume of a prism is length times breadth times height. So the volume of any prism is just area of the base times height. So let's continue. So now we've got pi r squared, pi r squared h. Okay, fine, there's nothing to manipulate. Okay, but we have the volume, right? So now we can say 340 is equals to pi r squared h. So now they ask us to represent h in terms of r, so we have to make h the subject of the formula. So in order to make it the subject of the formula, we need to remove these two stuff. So in order to remove it, because they're multiplying, we have to divide both sides by pi r squared. So when we do that, we're going to have h is equals to 340 over pi r squared. So this is what we have. This is our h. So now they said show that the surface area of the cone can be given by this. So now this also requires you to know the formula of the surface area. So I'm going to present all the formulas at the end, but most of the time when optimization comes out, it's not really going to be about knowing the formulas. It is weird questions that sometimes come out where you need to know the formulas. Yeah. But the thing that is a must is to know the area of a circle, which is pi r squared. But I'm going to show you most of these formulas, because you never know what might come out. So let's get the volume of the surface area of I'm gonna show you all the formulas at the end. So the surface area of a cylinder is known as 2 pi r squared plus 2 pi r h. Right? The fact that I can write it shows that it's memorizable, it's not hard, right? So 2 pi r h. So I'm going to explain this at the end. So let's do this. So this is the formula. So we don't have r, we don't have h yet, but we actually do have, right? So surface area, let's do this surface area. So show that the surface area can be given by this. Okay, fine, let's just change the symbol. So because it's area, so surface area. So all right, great. So now this is what we're going to do, right? Okay, I can explain this. Even if I don't explain this, you'll be good. So let me just explain this. All right, for instance, it's just like saying f at x is equal to 2x squared plus 2. So notice that because we're talking about it, the variable is x, we call it f at x. So this a of r, because the variable is r. So meaning that if you see that, it means that your variable must only be r. There must not be another variable. So, but anyways, don't worry about that. So you should just remember the pattern. We always make one thing the subject or a formula so that we can substitute it into the other equation. So remember, when it's 3D, we always need surface area and volume if there are two unknowns. So we use the equation for surface for volume in order to make something the subject. So once we have made that thing the subject, we can now substitute it into the equation for surface area. So here it's just 2 pi, and pi is not a variable, right? It's a constant, 0.14159 or something like that, 147, something like that. So that is pi, right? It's a constant, right? It's not a variable. So r squared is a variable, but we want it to be in terms of r. So we want it to be in terms of r. All right, so now we're going to have plus 2 pi r. So now the variable is h, right? H is equals to this stuff, right? So we're going to substitute it. So it means it's going to be 340 over pi r squared. So that's what we have. So now let's simplify the formula. So we've got pi r squared. Now notice this cancels this, and then r cancels one of the r squares. And then we're just going to be left with 2 times 340. 2 times 300 is 600. 40 times 2 is 80. So it's just going to be 680. Yeah, so this is what we have. Okay, so let's see how far are we from the answer. Okay, fine. So we see that it's almost the same. Here it's to the power of -1. So here's something. Whenever we shift something from the denominator to the numerator, it becomes negative. For instance, even with numbers, I'm allowed to shift it if I wanted to. If I shifted this 3 upward, it would have been 2 times 3 to the power of -1. If I want, I can also shift this 2 downwards. If I shifted it downwards, I would have been left with 1 on top, and it would have been 2 to the power of -1. So basically, when something moves from numerator to denominator or denominator to numerator, the sign of the exponent changes. So if this was negative and I shifted it upwards, it would have been positive, right? Even this 680, if I want to, I can shift it downwards and it can become 680. And then it can literally, 1 would be left on top and it will become 680 to the power of -1 over r, because it has an invisible exponent 1. So the sign of the exponent changes. So we're just going to shift that upwards. So it means it's just going to be, what did I do? That's plus. So we're going to have 680, and then we just shift this upwards. So when it moves from numerator to denominator, I mean to numerator, the sign of the exponent changes, and this is what we have. So now let's talk about this. Determine the radius that will ensure that the surface area is minimum. So notice something, right? So they're asking for the surface area to be minimum. So if they ask for the surface area to be minimum and there's two unknowns, they will give you the volume. If they instead ask for the area, I mean not the area, the volume to be minimum or maximum, they would have given you the surface area. So sometimes they can give you this question without asking you these previous questions. So they could have asked you this straightforward and said, determine the radius that will ensure that the surface area is minimum. If they do this, you know you have to create the equation for surface area because they want the surface area to be minimum. But then you would realize that we've got a problem. There are two unknowns. Then you'll have to create another equation for volume, and then you substitute the answer for volume. So it's always it's like that when there are two unknowns, right? So when there are two unknowns, they'll always give you the answer of one of them, and then they'll ask for you to make the other one maximum or minimum. So if they asked you this question straight, you would have done this by yourself. So whenever they ask you to do it, they've just made it easier. Alright, great. So now let's find the radius that will cause the surface area to be minimum. So this is the surface area. So now what we're going to do is that we're going to find the derivative, right? We want it to be minimum. That's why they wanted it in this form, so that it can be easy to derive it. So we're going to say the derivative, right? So area prime r is equals to, so that's what we have. So we're going to have 4 pi r, right? So let's just erase this part. So it's going to be 4 pi r. And then now we're going to have negative 680 r to the power of negative 2. Alright, so now we have to tell them the first derivative is going to be equals to 0, right? We'll also do that when we look for maximum or minimum. And then now this is going to be, so we're going to say 0 is equals to 4. Okay, fine, let me just change this. So it's going to be 4 pi r, then it's going to be 680. But if we're solving for x, when we want to derive, I would advise you to leave it in this form. But when we're solving for x, I would advise you to put it back down. So if you put it down, notice it's moving from numerator to denominator, so the sign of the exponent will change. So how do we get rid of the denominator? We have to multiply everything by the LCD, right? So notice that here it's just over 1 over 1, so therefore the LCD is just r squared, right? So the LCD is r squared, so therefore we're going to multiply everything by r squared in order to get rid of the r squared at the bottom. So then this is going to be multiplied by r squared, this is going to be multiplied by r squared. So this is going to be 0, and then we're going to have 4 pi r cubed, right? Because same basis we add exponents. And then this is going to be minus 680. So we take this to the other side. We're going to have 680 is equals to 4 pi r cubed. So now we're going to divide both sides by 4. So when you divide both sides by 4, let's see what it gives us. 68 divided by 2 is 32. Now 34. So therefore divided by 2 should be 17. So we definitely should have 17 pi r cubed. So in order to make r the subject of the formula, we have to divide by pi, right? So now we're going to have 17 over pi is equals to r cubed. And in order to get rid of the cube, we have to cube root. Just be careful, don't square root, cube root instead. Alright, so now this means that r is equals to the cube root of 17 over pi. No wonder they only asked us to solve for the radius. So notice they didn't ask for the maximum area. If they asked for the maximum area, the actual maximum area, we would have to substitute it into this formula. Right, great. Here is another one before we go here, before we look for some weird level. So they said, so they give you this particular shape, right? As we can see, it's a semicircle mixed with a rectangle. So now they said the figure above shows the design of a theater stage which is in shape of a semicircle attached to a rectangle. The semicircle has a radius r and the rectangle has a breadth b. The perimeter of the stage is 60 meters. So notice something, they gave us the perimeter, right? So I'm sure by now you should know this. So they give us the perimeter. So notice they said determine an expression of p in terms of r, even if they did not ask you the first question, because some questions can come out like the second question only. So even if they only asked you the second question and you see two unknowns, you know that you obviously have to, because it's a 2D shape. So 2D shape, we look at area and perimeter, right? Come on. I don't know why it does this. So we look at area and perimeter, right? So let me just write like this. So if they ask for the dimension such that the area will be maximum, and then we see that there are two unknowns, we have to create an equation for perimeter so that we can make one thing the subject of the formula in order to get rid of one unknown, right? In order to make something the subject, just like here. So if they didn't ask you this question, you can write B in terms of R, or you can even write R in terms of B. So for now, let's deal with the question since they asked us the question. So they said determine the expression of B in terms of R, right? So what is the perimeter of this stuff? So you have to be careful. I just want to show you something. So what is the perimeter of a circle? So this is another thing you must know by head. The perimeter of a circle is actually equal to the length of the circumference, which is 2 pi r. So the area of a circle is pi r squared, but the perimeter is 2 pi r. So the area of a circle, pi r squared, perimeter 2 pi r. So why am I showing you this? So it's important to know that if we talk about the perimeter of a semicircle, okay, notice that the area is kind of like how much space it occupies, right? So the area of a circle is pi r squared, but if we divide it by 2, the area of the circle will be pi r squared over 2. But we've got a problem when it comes to the perimeter of the circle. The problem with the perimeter of the circle is this. Now notice the perimeter of a circle, we know it's 2 pi r, right? But if we talk about the perimeter of a semicircle, it's not just 2 pi r divided by 2, right? So it's not just 2 pi r divided by 2. We have another side as well, which is this part, which is the diameter, right? 2r. So I hope you get it. So for instance, let's just say we've got a circle. Let's just show let me just show you a quick example because it's very important. This is literally what is important here as well. So I just want to show you something. Let's just say this is 10, right? So the area is obviously pi 10 squared, right? Which is the same as 100 pi, right? So now if they give you, I mean not the area, I wanted the perimeter, which is 2 pi r, right? So it means it's going to be 20 pi. And then now, if we talk about the perimeter of half of that circle, right? So let's just do something like that. So the radius is 10. So notice it's going to be 20 pi, or it's going to be not 20 pi, it's going to be 2 pi r divided by 2, which is just pi r, right? So it's going to be pi r, which is 10 pi. But we've got another length as well that we have to add, because every time we cut this, there is a surface exposed, there's a new surface, there's a new length exposed. So now it means it's going to be 10 pi plus 20, because this whole base is 20, right? So I hope you get it. So, but anyways, so it's very important, right? Just in case, what if they just give you a semicircle alone? What are you going to do? So just to cut it short, in order to get the perimeter of a shape, always count how many sides there are. If you count how many sides there are, you will never get it wrong. So notice how many sides are there in the shape. There is 1, 2. We don't count the interior part, right? So there's 1, 2, 3, 4. So notice we also don't include the top part of the rectangle as well. So we don't include the top part of the rectangle. We also don't include the bottom part of the semicircle, right? Because they're both covered. So it's just going to be 4 sides. So always count the sides before getting the perimeter. Same thing as surface area. When it's a 3D shape, always count the sides. So for instance, we do have a surface area of a sphere. But if they now ask for the surface area of a semisphere, we are not only going to consider half of whatever was going to be the surface area of the sphere, we're also going to consider the new surface that was exposed, right? So yeah, that's what you have to be careful of. So always count the number of surfaces so that it can help you. So let's do this. So now this is going to be 2r, right? Because notice this rectangle, notice this is r. If this is r, this r. So if this is 2r, that is also 2r. So obviously it's the same thing, right? We can even use this base instead of focusing on that if you want to. So that is 2r, and this is the breadth, right? So yeah, okay, fine. But anyways, I literally thought I was calculating the area, so we needed this side because we're calculating the perimeter. Okay, so but anyways, you agree, I'm sure you agree that it's 2r, right? So r and r, 2r. So this is B. Now what is this? this is half of the whole circumference, right? So therefore the circumference, remember, is 2 pi r. So half of the circumference is 2 pi r over 2, which is just simply the same as pi r. So what is the radius? Well, the radius is literally r. So we're going to say pi radius, right, plus 2r, which is this, plus b, right? It's the same as saying plus 2b, but I'm just taking the long cut just. So then we're going to have this, we're going to have 2r, then plus 2b. Alright, so if they ask us to write that, that is the perimeter, by the way, the perimeter. So the perimeter is 60 meters, right? So we're going to say 60 is equals to, so come on, 60 is equals to pi r plus 2 r plus 2b. Alright, so now write b in terms of r. Okay, so I'm just going to show you something. So let's just first of all take everything to one side of the equation. So we're going to have minus pi r minus 2r, then this is going to be equals to 2b. So we're going to divide everything by 2 in order to make b the subject of the formula. So therefore this is going to be 30 minus pi r over 2. Then this is going to be minus r. So this equals to b. So therefore we've got our answer of b in terms of r. So b is equals to 30 minus pi r over 2 minus r. Alright, let's go for the next question. So let's go for the next question. Let's just do this. Okay, so let's just erase this particular stuff. Alright, so now notice something, right? So the next question says, for which value of r will the area of the stage be maximum, right? So remember, they could have asked you this question without asking you the first question. So if they ask you for this question without asking you the first question, you would have created the formula for area, then you would have realized that there are two unknowns. So if there are two unknowns, we know that when it comes to 2D shapes, it is area and perimeter, right? So meaning that you would have to create another formula for perimeter and make something the subject of the formula. So therefore you can write b in terms of r or r in terms of b. That's if they didn't ask this question, right? Then you'd be able to substitute it into the final formula and make your area minimum. So here, because they ask us to write b in terms of r, we have to make sure b is instead written in terms of r. Alright, so now they ask for the value of r such that the area will be maximum. So now let's talk about the area. Remember, when it comes to area, right, it's the area of a semicircle is just going to occupy half the space of the area of the okay, I just got distracted by something. So the area of a semicircle is just going to occupy half of the space of the area of a circle, right? So the area of a circle is pi r squared, therefore the area of a semicircle is pi r squared divided by 2, right? So this part is a semicircle, so that is why I'm mentioning that part, right? So it's going to be the area of the semicircle plus the area of this shape, right? So it's going to be length times breadth. So the length is 2r, right? Why is it 2r? Is 2r because we've got r here and we've got another r here. So if this is 2r, that has to be 2r. But either ways, it doesn't matter which one you refer to. Remember, it's just length times breadth. You can take this one or you can take that one. So we have pi r squared divided by 2, which is the area of the hemisphere, and then the area of the rectangle is length times breadth, right? So we almost sorted. So let's see how it goes. So first of all, area, so let's just write it, area is equals to pi r squared over 2 plus 2rb, right? Let me just write it below. So I've written it below. So the nice thing is that we actually do have b. So then it's going to be pi r squared over 2. Then we're going to have 2r. Then we're going to have 30 minus pi r over 2 minus r. So then let's simplify it. So this is going to become over 2. Then we're going to have 60r. And then this is going to be, so this 2 will cancel with that 2 there. So now we're going to have minus pi r squared. And then this side is going to be minus 2 pi r squared. Okay, what did I say? Yeah, it's fine. That was it. Okay, so Now we know we have to find the derivative, right? So let's find the derivative. Let me see if there are any like terms. What did I do here? This is pi. So that is pi. Alright, so that is pi. So you can derive it immediately if you want to. You can derive it, but now I'm just going to choose to group the like terms. So here we've got pi r squared, we've got r squared rather, and r squared. Also these are like terms, but honestly, to mix two with pi is going to be something. But because these ones are mixable, this is going to be like saying half minus 1, which is minus half. So we have minus pi r squared over 2, then we're going to have plus, okay, yeah, plus 2r squared plus 60r. You can immediately derive this, absolutely no problem. So let me just derive from here. So let me call this, let's call this a at r, because it's written in terms of r. So now we're going to find the derivative of a at r. So then this is going to be so we're going to have, so this is going to cancel with the half. So now we're going to have negative pi r. So we literally have negative pi r. Then this side we're going to have plus 4 pi, and then plus 60. Yeah, literally that's what we have. All right, great. So now let me just say something. Yeah, okay, fine. I thought there was a mistake somewhere. So now we're going to tell them again the first derivative, right, is equals to 0. So therefore 0 is equals to, okay, let's just do this. So 0 is equals to minus pi r plus 4r plus 60. All right, great. So we can group this, right? So first of all, yeah, let's just group it. Okay, fine. Let me just take this to the other side of the equation first. This is going to be minus pi r plus 4r. So we can factorize so that r can become the subject of the formula. Whenever you have things that you can't add, but you want to make something the subject and it's on both of them, you just factorize. So then it's going to be plus 4. So now we're going to have minus 60. So therefore, r is going to be equals to minus 60 over minus pi plus 4. Yeah, so I want it to be positive. So I'm just going to multiply by negative so that it becomes 60 over pi minus 4. Yeah, so basically that's what we're going to have. Yeah, because if I took 60 this side also, if you get confused by this, I just factorize negative and then I cancelled it. But what you could have done also is just to take 60 this side so that it's positive and r that side with the 4. Yeah, but either form should be correct anyways. So there we have it. We got r that causes the area of the stage to be maximum. Alright, so now they said a piece of wire 6 meters long. Whenever they give you the length, you indirectly have the perimeter. You should attack it immediately. So I'll show you what I mean. So a piece of wire 6 meters long, it's cut into two pieces. So first of all, we've got the wire which is 6 meters, right? So let's just do this. So this is a 6 meter long wire, and then it's cut into two pieces, right? I'm not saying it's divided into two. We don't know where is it cut, but it's cut into two pieces. That's what we know. So this 6 meter long wire has been cut into two pieces. So now they said one piece x meters long is bent, so meaning that this piece, let's say this piece, it can either be this piece or this piece, but let's just choose this one to be x. So one piece x meters long is bent to form a square. So it means that it's going to form a square, right? So immediately you must know that we have the total, right? The total of the perimeter is actually x. The total of the perimeter of this is x, right? So when they tell you it's a square, there's many things you can do with it. There's rather many things you can do when it comes to properties of shapes, right? So notice they tell us that this is a square. So immediately we know that all sides are equal. So immediately you should be aware that each side is just going to be x over 4, all right? So if it was a rectangle, we won't really know the exact sizes, right? But yeah, we won't really know the exact sizes. So it's a square. So because all sides are equal, we immediately divide by 4. So when it comes to optimization, you have to know properties of shapes, right? And you have to take advantage of whatever they give you. So you have to think above what they give you. For instance, they gave us that this is x, the whole length is x. Now we see that it's a square, so we had to divide everything by 4 and call each side that length. So I hope you get it right. So we know that it's going to be x over 4, x over 4, x over 4, x over 4. So the total is x, because they tell us that this length x has been used to form a square. So we know that the square is all sides equal, therefore it has to be divided by 4. So now, here's another thing you have to do immediately. Notice in Euclidean geometry, if they give you something like maybe AB, and let's say C, let's just say it's C here. So now if they tell you that AB to AC is, AB to AC is maybe 3:2. This is what you would do. You say AB is actually 3x, and then AC is 2x, right? But you won't just stop here, right? You have the total length and you've got this. Immediately when you see this, whenever you've got the total length and you've got one piece, make sure immediately you get that piece before you end up forgetting. So notice that we've got the total, which is 3, we've got the side, which is 2, so we have to get this side by subtracting them. 3x minus 2x is x. So this is what we'll do in Euclidean as well, right? So if we've got a total and we've got one piece, we have to immediately get the other piece. So same thing here. Notice that you have got the total and then one piece is called x. You must immediately take advantage of this and call this one 6 minus x. So it means that the other part will be 6 minus x. So they said something. They said the other piece, right? The other piece is bent into a U shape that forms a rectangle BEFC when placed next to the square as shown in the diagram below. So they're just saying that the other piece is formed into a U shape, right? So it's bent into a U shape. When it's bent into a U shape and we combine it with this, it forms this rectangle that we see here. So notice we also have the total of the other piece, right? 6 minus x. So we've got a problem. First of all, notice that we can't tell how it's splitted. We really can't tell how it's splitted, right? But here we could, here we couldn't, right? So it's not hard, it's just common knowledge. Right here it was common knowledge, but here it isn't. So the sum of the areas enclosed must be maximum. All right, great. So we have to get that. So before we get that, let's just fix this. Alright, so now I just want to show you something. This is x over 4, this x over 4, this x over 4, this also x over 4, right? So now what you have to do immediately is to use wisdom and notice that this whole thing is actually a rectangle in itself, right? So because this whole thing is a rectangle, we can actually say this side is equal to this side. So therefore this side actually becomes x over 4 as well. Here. So now the only part we're left with is to get this part and this part. This 6 minus x is actually not for this length, right? It's for the total. So how can we get this length and this length? Well, it's not going to be hard. Let me show you something. So we know that BE plus CF plus x over 4 is equals to 6 minus x, because the whole length is 6 minus x. The next thing is that a lot of past papers won't come out like this. So if you see this as a weird level, don't worry about it. But all the skills that I'm showing you is actually what will help you in all the other past papers as well, right? So so notice that this, we have the total, which is 6 minus x, right? So now because this was equals to this, it becomes x over 4. So now here we just have to extrapolate and notice that this is 6 minus x and this is equals to this, right? So notice, for now we know that this plus x over 4 is 6 minus x, right? But these two are equal, you see? So notice these two are equal. So meaning that we can just use the same letter. You can solve it anyhow. This is one of the ways of solving it. We can just use the same letter for both of them. We can just say BE plus BE because they're both the same, right? So it means that 2BE, because BE plus BE is 2BE. So this plus x over 4 must be equal to 6 minus x. So let's just go further. So it means that 2BE is going to be equal to 6 minus x over 4. So now it means it's going to be 6 minus 5, because if you type this in the calculator, if you type minus 1 over 4 is minus 5 over 4. Yeah, but without the calculator, mathematicians have no, right? Those who are planning to do science courses at university, you have to be able to do this without a calculator. So yeah, when you divide both sides by 2, because we want to get BE, right? So when you divide both sides by 2, what you would do is that you will just divide everything here by 2. So it means it's going to be 6 over 2, which is 3. And then minus 5 over 4 over 2, you can type that in the calculator. In the calculator, don't type minus 5 over 4 over 2, because some people actually type it like this. They actually type it like this and they get it wrong. Okay, I meant for this to be 2. They get it wrong. Maybe they meant this, but they type this. So in order to avoid that confusion, is whenever you've got fractions, don't type complex fractions in a calculator. It's better to type minus 4 divided by 2. If you have got maybe 5 over 4 divided by 2 over 8, don't type this in the calculator. In the calculator, type 5 over 4 divided by 2 over 8. Then you'll avoid mistakes. So yeah, just avoid complex fractions in the calculator. So this divided by 2 is going to be 5 over 8x. So that's what we have. We've got BE 5 over 8x. So let's just do that. So okay, let's just erase this first part. So it's going to be 5 over, what did I do? It's 3 minus 5 over 8x. So 3 minus 5 over 8x. So we immediately have everything, right? So whenever they give you a length of a wire, we have the perimeter, right? So notice something. So notice something. They want the area, right? So they said calculate the value of x for which the sum of the areas enclosed by the wire will be maximum. So they're saying the sum of this area and this area. I don't know why they did this. I guess they were trying to confuse you. If they ask for the sum of this area and this area, they're actually indirectly asking you for the whole shape, the area of the whole shape. They could have just asked you for the area of the whole shape, right? So let's just pretend that they ask us for the area of A, E, F, D, right? So they ask you for the area of A, E, F, D. Let's pretend that they ask you for this area. So what you will do is that, so we pretend that they ask us for this area. So we just have to get the area, right? So now we know that area is equals to length times breadth. So area is equals to length times breadth because it's a rectangle. And then now notice something. Notice that we do have the length, right? We have the length and the breadth. So the length is literally, remember this part is x over 4. So we literally have to add this. So yeah, so it's just going to be 3 minus, okay, 3 minus, let me just write it down here in order to avoid all confusions. So it's going to be 3 minus 5 over 8x, and then we had plus x over 4, right? So now we have to do with fractions here. Let me try and do it without the calculator since I do not have one. So this is the same as 2 over 8 minus 5 over 8. So it's going to be minus 3 over 8. Yeah, that should be it. So this is the length. So it means that the length is, what did I get? It was 3 minus 3 over 8. Yeah. So 3 minus 3 over 8. So that is the length. So now let's get the breadth. It's x over 4. So let's simplify this equation. So we distribute, we're going to have 3 over 4x, right? If you type 1 over 4 times 3 in the calculator, you just get 3 over 4. And then if you type if you get that, that's going to be 3 over 32. Yeah, so that's what we have. X squared, yay. Just have to be careful. Yeah, X squared. So this is a parabola. Notice we have this situation again. They ask for the maximum, so that's how we know we're on the right track, right? So, and this is a parabola, right? So notice that the value of a is negative, right? Because a is what is in front of x squared. So now you know we have to get the derivative. So let's get the derivative. Let's get the first derivative. So let's just call it like this. I like calling it like this. It's much more better. So the derivative of this is just going to be 3 over 4, and then we're going to have 3 over 16x. So you're going to tell them the area, the derivative of the area must be 0. right? Every time they ask for maximum or minimum, you always do that. So then it means it's going to be 3 over 4 minus 3 over 16. So let's solve it. So now if I take x to the other side of the equation, I'm going to have, if I take this to the other side of the equation, I've got 3 over 16, x is equals to 3 over 4. Okay, so how do we get rid of this? If you want, you can cross multiply and stuff, right? Or you can multiply by the LCD, right? So yeah, let me just choose to multiply by the LCD, which is 16. So times 16 times 16, so 16 will cancel, and then it's going to be 3x, and then this is going to be 12. So I divide both sides by 3, I get x is equals to 4. Yeah, so now I've got x is equals to 4, so we're done. It means that if x is equals to 4, it means that this is 1 over 4, 1 over 4, 1 over 4 and stuff. So we found x, right? But what did they ask for? They asked the value of x. We actually stop here. I was thinking of going further. Yeah, they didn't ask for the maximum area. They didn't ask for the maximum area and stuff. They asked for the value of x that will result in a maximum area. Alright, here is an asked question. They said a wire 12 meters long. So let's imagine a wire that is length 12 meters long. So they said it's cut into 2 pieces. So we don't know whether it's cut into half or whether one side is longer than the other. So we really don't know. Then they said one part is bent to form an equilateral triangle and the other a square. Alright, great. So they took this one, they made it an equilateral triangle, and then they took the other one, they made it a square. So, okay, let's just do this. So they made it a square. Come on, let's try one more time. So they made it a square. Okay, fine, something like that, right? So now, let's go further. So let's see, what did they say? Then they said, write down the, okay fine, let me just see something. The side, so I didn't read this part. They said a side of the triangle has length. Okay, a side of the triangle has length 2x. So they're telling you one of the sides is 2x. But remember, it is an equilateral triangle. Therefore, all the sides has to be 2x. So, notice this is going to be 2x plus 2x plus 2x, 3x, right? Whenever they give you length, you always have to find the way to relate what is given here to here or what is given here to here. What do I mean? So notice that this is 2x, 2x, 2x. It means that this part is actually 6x. So now we have this part, 6x. So the nice thing is that we can get the other part, right? So let's get the other part. So we know that when we have this part and we have the total, we can get the other part by just subtracting them. So let's just remove this meter so that it doesn't look like it's a variable. So this is going to be 12 minus 6x. So we have 12 minus 6x. Come on. So let's just fix it. So we're going to have 12 minus 6x. All right, great. So that's what we have. Write down the length of a side of the square in terms of x. So now we have this part, right? So whenever you've got this part, notice it's a square, right? So because it's a square, it means that we can just divide by 4. So if we divide by 2, let me divide by 2 first. If we divide by 2, it's going to be 6 minus 3x, and then I'm going to divide by 2 again. Alright, so now notice something. So this is a square, so we're just going to divide it by 4 because remember a square has 4 equal sides and all of them have to add up to this stuff, right? So we divide this by 4, so this is going to be 3 minus, remember 6 divided by 2 is 3, then divide by 2 again is 3 over 2, so this is just my own weird way of calculating it. So so it means that each side is going to be 3 minus 3 over 2x. Let me just write it a bit better. So 3 over 2x. Alright, so that's for each side. So now we got the length of a side of the square in terms of x. So now they said if the square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Well, the nice thing is that we only have one unknown. so we don't need to create the formula for surface area. So this is now a base of a rectangular prism. Let's just draw something like that so that it can be more clearer. So something like that. So let's just do this. Let me just fast forward. Alright, so here is something, although it's not exactly what I want. So this is going to be 3 minus 3 over 2x, right? So we took this as the base, right? So that's what they said. So the square is now used as the base of a rectangular prism. Now with a height of 4x, so the height is 4x. So now they ask for the maximum volume. So what is the volume of any prism? Is area of the base times height. So the area of a square is length times breadth because it's a rectangle as well. But because all sides are equal, we just say side times side. So it's going to be the volume. Okay, so let's do this. The volume. So we'll write first that volume is equals to area of the base. So area of the base, forgive my handwriting, times the height, right? So that's what we'll do. Alright, let's go forward. So the area of the base is 3 minus 3 over 2x, and then we're going to have 3 minus 3 over 2x, and then we're going to have times 4x, right, which is the height. So area of the base times height. So now let's multiply this. You can distribute with a calculator and stuff, but I'm just going to get straight to the point. This is going to be 9 minus 3 over 2 times 3 is like 9 over 2 times 2 is 18 over 2. Really, so which means it's going to be 9. Okay, so then the side is going to be 9 over 4 x squared. Yeah, so I'm just going straight to the point. So then this is going to be 4x. So now let me distribute this stuff. So let's distribute. So if we distribute, it's going to be 36. Come on, it's going to be 36x minus 36x squared. Then this is going to be plus. This cancels, so it's purposefully done. So then it gives us 9x squared, 9x cubed, I mean. Okay, so that's the volume. So let me just say volume in terms of x. Yeah, so that's what we have. You can write that from here if you want to. Yeah, I mean, yeah, we should write that from here. So yeah. Alright, so now let's get the first derivative. So we say that we have got the full form. So this is going to be a cubic graph, right? So now let's get the first derivative. So we're going to say the first derivative of the volume is going to be equals to 36 minus. Now this is going to be 72. So 72x. Then we're going to have plus 27x squared. Right, so they asked, so notice that this is going to be, so it's a cubic graph, right? The cubic graph has got both maximum and minimum. But if it was a parabola, we would be able to really tell if we're at the right track or not. But the cubic graph has got both maximum and minimum. Hence, when we find the first derivative, there's going to be two values. So after getting the first derivative, we have to tell them the first derivative must be equals to 0 because we want to find maximum or minimum, right? So they ask for the maximum value. So we're going to say 0 is equals to, let me just rearrange it. So this is going to be 27x squared minus 72x plus 36. So everything we can see is divisible by 9, right? So it's divisible by 9. Yeah. So let's divide that by 9. So 27 divided by 9 is 3. And then 72 divided by 9, I think it's something like 8. Yeah, it has to be 8. So yeah, it's definitely 8. So it's going to be 8x, and then there's going to be 4. All right, great. So looking at this, yeah, so this is the type of graph that we have. So you can just type this in a quadratic formula. If I choose to do it without the quadratic formula, it's going to be 12. So we need two numbers that can give us 8, which is 6 and 2. So it means I'm going to say 3x squared is going to be equals to minus 6x minus 2x plus 4. And then this is going to be 3x, and then when I factorize this, it's going to be x, and then it's going to be minus 2. Yeah, minus 2. and then because there's a minus here, I factorize minus, then it's going to be 2, then it's going to be x minus 2 again, because positive divided by negative is negative. So then this is going to be 3x minus 2. So without the calculator, if you know this method, you would know you're on the right track when the brackets are the same, right? So this is going to be this part. So therefore, we're going to have 3x is equals to 2, and then x is equals to, okay, yeah, 2 as well. So this means that x is going to be equals to 2 over 3, or x is equals to 2. Okay, fine. So how do we know which one is right between the two? So there are two values, right? We can use the second derivative test, but honestly, we don't need to use the second derivative test. So notice the cubic graph is in the form of ax. Where is that? So the cubic graph, where is that cubic graph? So notice it's in the form of ax cubed plus bx squared plus cx plus d, right? So if we arrange it in order, a is 9. So notice that whenever a is positive, the cubic graph is increasing overall. Whenever it's negative, it's decreasing overall. So we know the right shape is going to be this one, right? So it means, and notice this x value in the horizontal, this x value will come first. 2 over 3 will come first before 2, because 2 is smaller than, 2 over 3 is smaller than 1, right? So it means 2 over 3 will belong to the maximum turning point, and 2 will belong to the minimum, right? So notice there's the local maximum, local minimum. So you have to be careful. So you don't just take the higher one and say, yeah, the higher one will be maximum. No, these are the x values. You can substitute them into the original equation to take the higher y value if you want. But even without doing that, just by knowing the shape of the graph, we can tell which x value will come first, and then we can therefore tell which one will belong to which. So if it was like this, for instance, we know that this x value is always first. Still, it's going to be 2 over 3, and then this is going to be 2, right? So it means that 2 over 3 would have belonged to the minimum, and 2 would have belonged to the maximum. So therefore, we see that 2 over 3 belongs to the maximum, so it means we'll take this point, right? So therefore, x is not equals to 2, x is equals to 2 over 3. So let's continue from here. Let's see, did they say find the x value, or they said find the, let's just see what they did. This they said determine the maximum volume, right? So therefore, we have to substitute the x value into the volume formula. So we're just going to take this volume formula and substitute the x value. So we're going to type in the calculator, we're going to say 36 into 2 over 3 minus 36. And then we're going to have 2 over 3 squared. And then we're going to have 9. And then we're going to have 2 over 3. So this is what we have. So let's just find out what that will give us in the calculator. So this is volume with volume in terms of x, right? So volume at x. So let's find out what it will give us. So the answer is going to be 10.67, right? So let's see if they gave us any units. Obviously, they didn't give us. Okay, fine, they did. If they didn't give us any units, we're going to say units cubed, but they said for x meters. So therefore, it's going to be meters, right? Meters cube, right? Volume is in cube, area or surface area is in squared. Perimeter is just in unit. Alright, so now before we go to something that is a little bit different, let me show you a basic example of it, which also appeared in one of the past papers. I just don't remember which past paper it was. So let's just say we've got something. Let's just say we've got a material, right, that we want to use for fencing. So let's say that material, let's just say we've got a certain material that we want to use for fencing. So we've got a long strip, right? So let's just say we wanna use it for fencing. So let's just say this is a river, and we wanna be able to fold it into a U shape so that it forms a rectangular shape with the river, right? So we have got a long material which we wanna use for fencing, right? And then now let's say they tell you that the cost of fencing parallel to the river is, let's say, 40. So 40 rands per meter, right? So let's just say the cost is 40 rands per meter for fencing parallel. So for fencing parallel, let's just do this for fencing parallel to the river, right? And then let's say they tell you that the cost of fencing perpendicular to the river or at right angles to the river is, let's say, 30 rand per meter squared, right? 30 rand per meter, not per meter square, I mean. So the cost of fencing at right angles to, so let me just do this. So the cost of fencing at parallel to the river is 40 rands per meter, right? And then the cost of fencing at right angles to the river, meaning that if you wanna fence this part and this part, right? So that those are at right angles to the river. So the cost of fencing at right angles to the river is 30 rand per meter, right? So now they ask you, let's say they tell you that the area, so they tell you, so let's just remove this, so we know that is what is going to be used to fence, right? So now let's just say they tell you that the area, so the area has to be 100 meters squared. So this must be the area, right? So now they ask you, calculate the dimensions that will result in a minimum cost. So how are we going to form the equation? So let's just write the stuff with it. So they want the cost to be minimum, right? So minimum cost. Okay, so minimum. Yeah, I don't think I spelled it right, but anyways, let's just proceed. Let's just do this min, right? So they want the cost to be minimum. So because it's a 2D shape, it's area and perimeter. So is the cost going to be the area or is it going to be the perimeter? Notice that they said the cost must be minimum, right? So the cost depends on the length of the material used. That is how we know it's going to be part of the perimeter, right? So it's going to be the perimeter, but it's not going to include the river because the cost is only 1, 2, 3, right? So this appeared in the past paper. It also appeared in the textbook, but it appears in the past paper as well. So let me show you a difference. Let me show you something that is important. So because they said the cost, right, we know that it's going to be the perimeter. But if they had said the painting, right, if they say the painting of a 2D shape, then it's going to be the area. So it's going to be obviously the area. So if they ask of the amount of paint, is the area. If they ask for the cost of the material used, because it has to do with length, is the perimeter, right? Because honestly, this is not going to like cover the whole thing, right? This is just a long wire that has been bent into a shape. So the cost, therefore, of the fencing is just the perimeter. So let me just show you something. Let's talk about the 3D shape as well with this kind of situation, right? So if they give you a 3D shape, for instance, and then they tell you that they want the amount, so they say the amount of maybe water has to be, so the amount of water put in this container has to be minimum. Because it's the amount of water put in this container, it is the volume, right? So volume is like the capacity, right? The amount of space it takes up. So if they had said the amount of water, for instance, or the amount of liquid, then it would be the volume. But if they said the material used to create this stuff, then that's the surface area, because the materials are like the walls, right? So we're going to have this surface, the bottom one, right? So it will depend. Maybe it can be open, maybe it can be closed. So if they say the amount, they're talking about surface area. If they say the amount of metal used, they're talking about surface area. It's almost like the amount also here when we're talking about the perimeter, right? So which is the length. So in 2D shape, if they ask for the amount, it is the length. If they ask for the painting, the area. But in 3D shape, if they ask for the amount, that is the surface area. If they ask for maybe something that will fill it, then that is the volume. All right. So here, because they say the cost must be minimum, the cost depends on the length. So therefore, the cost is going to be the perimeter. So now we know we're going to create two formulas for the perimeter and the area. So the cost must be minimum, meaning the perimeter must be minimum. And then why are we given the area? Because we know there's going to be two unknowns, right? So that's why we're going to need both the formula for area and perimeter. So let's talk about this stuff. How are we going to do this stuff? Whenever they say 40 rand per meter, right? Whenever they give you an amount per something, you are going to say that amount of X. It's a usual thing. Different types of past papers appear in this way. If they give you the amount per something, you put that amount per X or per Y or per any letter, right? So notice they said the the cost to fence parallel is 40, right? I don't know if I switched it, but the cost of fencing parallel is 40. The cost of fencing perpendicular is 30. So because the cost of fencing is parallel, let's just call this Y, for instance. Let's just call it Y. So this is Y, This is x and x. Why do we give them different letters? Because this is not the same as this length, right? However, this and this length are the same. So this and this length are also the same, but this is the river, so it's not part of the material. So notice they said the cost of fencing at parallel to the river is 40 rand per meter. So therefore you're going to say 40 rand per y. Right, so if y was maybe 30 meters long, it means it's going to be 40 rand for each meter. So therefore, the total will be 40 times 30. That is why whenever they say a cost per something, we always put that cost and then times it by the variable. So same thing we're going to do here. This is 30 per meter, right? And then this is 30 per meter. It's just that this total length of meter is not the same as this total length of meter. That's why we give them different letters. So let's talk about the perimeter. The perimeter, we're not going to include the river because the cost only depends on the material, right? All right, so now we're going to say the cost. So the cost is equals to the perimeter of this stuff, right? So it's going to be 30x plus 40y plus 30x. So therefore, it's going to be 60x. So it's going to be 60x plus 40y, right? So, okay, fine. So I wrote it here. That's why it appears like this. Let's just write it here. So it's going to be 60x plus 40y. So we've got a problem. There are two unknowns, right? How do we deal with it? We know we have to have another formula, which is going to be the formula for area, right? Because it's a 2D shape, area and perimeter. So we could have actually created the area part first before this part. So they gave us the area. So first of all, area is equals to length times breadth since it's a rectangle. So therefore, area is equals to the length, which is this part, 30x, times the breadth, which is 40y. Okay, fine. The real length is 40y and the breadth is 30x, but the order doesn't matter. So then this is going to be 1200xy. So we now know, we actually know the answer of area. So whenever you have two unknowns, then you have to use two formulas. They will give you the answer of one of them. So 100 meters squared, so it's going to be 100. So therefore, if we make anything the subject of the formula, right? Notice we had to create it ourselves, but if they want to make the question easy, they would actually ask us and say, show that x can be written as maybe something over y, or show that y can be written as something over x. Or they can say, find x in terms of y, or find y in terms of x, right? So that can be the first question which will require this formula before they finally ask you for the minimum cost. But here they just ask you for the minimum cost, meaning you have to do everything yourself. So we can choose which one we want to make the subject of the formula. So first of all, let me just simplify this stuff. Okay, fine, let's just do this. Let's just make y the subject of the formula. So if I make y the subject of the formula, it means that I'm going to divide both sides by 1200x and then 1200x. So therefore, this will cancel this. So I'm going to be left with 1 over 12x. So that's y. Yeah, that is literally y. So now when I come to this formula, we can replace y with this stuff, right? So so that we can now have one unknown. So 60x plus, come on, 60x plus 40, and then y is 1 over 12x. Alright, so that's the cost. So now it's going to be 60x plus. Okay, so this can divide. So let me just say something. If I make it 4, if I take 4 as my highest common factor, 4 is my highest common factor. So 4 into 40 is 10, and then 4 into 12 is 3. So this is what I have. Because you can even type 40 times 1 over 12. The calculator will give you the answer. So it should be 10 over 3. All right, so this is what we're going to do. So let me just say something. So now they want the cost to be minimum, right? So for us to get the minimum, we have to find the first derivative. But before finding the first derivative, we have to make it into a differentiable form. So because x is here, we have to put it up. So it's going to be 60x plus 10 over 3 x to the power of minus 1. So putting it on the side is the same as putting it up. It's the same thing. So because we have to make it into a differentiable form, remember when something moves from denominator rather to numerator, the sign of the exponent changes. So then now we can find the first derivative. So let's just say, so the first derivative. So let's just do this. So this is going to be 60 plus, okay, minus actually. So this was 10 over 3. So it's going to be minus 10 over 3x to the power of minus 2. So meaning that, and we're going to tell them the cost must be equals to 0. So 0 is going to be equals to 60 minus 10 over 3x to the power of negative 2. So there's many ways to solve this. There's literally many ways we can solve this, right? So yeah, let me use one of the ways. So I'm just thinking there's many ways. Okay, fine. Let me present both of them. So here are two ways. One easy way that is probably not known by a lot of people is to say 10 over 3x. Okay, it's known, but it's rarely used. 10 over 3 to the power of minus 2 equals to 60. So I just took this to the other side, right? So now in order to get rid of this fraction, I can just multiply by the reciprocal. You can choose to divide both sides by 10 over 3, but why not just multiply by the reciprocal so that this cancels this cancels this. And then this is going to be equals to 18, literally 18. So if you have this, you can just multiply both exponents by negative half, literally. So it means this is exponent 1. Be careful not to multiply 18, but multiply its exponent by negative half so that it cancels, right? So this is one of the ways. So this is one of the ways. So then it's going to be 18 to the power of negative half, and then you can just get the answer. So I don't feel like getting the answer. Besides, I just said this question, but it appeared in the exam. But honestly, just type this in the calculator and you'll get your answer. So that would be, they asked for the minimum cost. Okay, fine. We're going to have to get the answer so that we can substitute it into the formula. Okay, let's present another way as well. What's the other way I was thinking of? So we can do the same thing. Okay, fine. Without doing the same thing, there's another way I was thinking of. So even if we don't shift it at the top, right? Even if we have 10 over 3 to the 3x squared, we can just take this to the other side of the equation, 3x squared, and then we can cross multiply, right? So we can cross multiply so that this is just going to be 3x times 60. This is going to be 180. Yeah, so x squared equals to 10. And then now we divide both sides by 180. So 180, so that we can be left with x squared is equals to, this cancels, so now we've got 1 over 18. It's one and the same thing, right? So so that we can square root both sides. So when you square root both sides, we're going to have x is equals to the square root of 1 over 18. Yeah, but anyways, I don't want to get the answer so that we can do the actual past paper quickly. So we're just going to take this, whatever answer we have, we're just going to take it and substitute it into the formula of the cost, right? So there's no need to find y. We can just substitute it into the part where it was x's only, right? So you substitute it into this formula. Yeah, so you substitute into the formula, and then you end up getting your maximum, your minimum cost. Yeah, so that's how it is. So let's go for another question. Great, here is the biggie. So now they say a closed rectangular box. So they have to tell us it's closed, because when they give us a rectangular prism, it can be an open or a closed box, right? It can be one with an open lid or a closed one. So if it's an open lid, it means when you consider the surface area, you'll take all the surfaces except the top. If it's a closed lid rather, then it means you'll take all the surfaces, including the top, right? 6 surfaces. But anyways, let's go further. So a closed circular box has to be constructed as follows. So now they say the dimensions, length, width, and height. And so we have got, let's just draw the box. So let's just do that. So let's just draw the box. All right, great. So here is the box. So it has to have the length, the width, and the height. So the volume has to be 5 meters cubed. Okay, let's do this. I just want to check something before we get there. They said the length of the base has to be 3 times the width. So the length has to be 3 times the width. So it means the length is equals to 3W. So meaning that we can substitute length with 3W. So I was worried that what we've got 3 unknowns, which is not a problem, it's solvable, right? But anyways, we now have 2 unknowns. So why are they giving us the answer of the volume? They're giving us the answer of the volume because we're going to need two formulas, right? So we're going to need the formula for the volume and obviously the formula of the surface area. Alright, so now let's create the formula for surface area. So before we create the formula for surface area, remember the cost is 15 rand per square meter for the top and the bottom, right? And then 6 rand per square meter for the sides. So now, what is surface area? Surface area is just the total area of all the surfaces, right? So it's like adding this area, that area, that area, and that area, and that area. So adding the areas of all 6 surfaces, that is surface area. So let's get the area of the bottom part first. So what is the area of the bottom part? So, okay, let's do this. So the cost also depends on the area. So the cost is the surface area. So now what is the area of the bottom part? So the area of the bottom is a rectangle, so it's length times breadth, right? So it means it's 3W times W. But we've got a problem. The cost is per square meter. So every time they say per, if it's a square meter, you have to multiply the area by that cost, right? If it was the length, we would have to multiply the length by that cost. If it was maybe, for instance, the cost is 15 rand per meter, we would have multiplied this by 15, right? We would have multiplied the length by 15, but the cost is 15 rand per square meter. So because they say per square meter, it means whatever square meter we have to multiply it by that. So it's 15 rand per square meter. So notice that this stuff is actually the same as the one on top, right? So you can repeat it or you can just multiply it by 2, right? So 3W times W. So forgive my handwriting there. So 3W times W, right? So we have the top and the bottom part. So 15 rand per square meter. So it means whatever area we find, we have to multiply it by 15. So now let's find the ones of the side also. So this one is height times h. What am I saying? W times h, right? So it's W times h. However, we have to multiply it by the cost of the side. They say it's 6 rand per square meter. So 6 times this stuff. And then there is another one similar to it, right? So it's going to be 6W times h. And then let's talk about the one in front. The one in front is 3W times h because this is the same as h, right? So it's going to be 3W times h, and then it's part of the sides also, so it's going to be 6 rand. And then we have another one behind that looks the same as it, right? So it's going to be 3W times h. All right, did we add all 6 sides? Let me see something. Yes, we did. 2, 4, 6, so we've added them. So let's simplify this stuff. So therefore it's going to be 15 times 3 is 45. So we're going to have 45. Okay, fine. Let's just add them once. I mean, honestly, let's just add them. 15 plus 15 is 30. So 30 times 3 is 90. So 90W squared, right? I just added this. You can add it in any way. If you get confused, you edit, you'll see the answer will be the same. So then we have 6 plus 6, which is 12. So we're going to have 12WH. And then we have got 6 plus 6 again, which is 12. And we have to multiply by 3, right? So it's going to be 36WH. So now let's add them, right? So if you want, you can multiply and say 6 times 3, 18, and then 6 times 3, 18, and then 18 plus 18 is 36. So now let's see if there's any like terms. So this is 90W squared, and then this is going to be 36 plus 12 is 48. 48WH. So that is the cost. Let's see if it is the same. And boom, it is the same. So we got the cost. Now let's deal with the last question. Honestly, if you got this correct, the funny thing is if they do this and you get stuck, do not undo the next question just because you couldn't get this. You can just copy the answer from here and you continue and you get your 6 marks. At least you would have passed this question. So whenever they do that, even in trig, if they say hence, use the previous answer to help you get the next one, even if you didn't get the previous answer correct. I'm going to make a video for hence so that you see the general pattern when it comes to trig. So that's what we have. Yep. So now they say determine the width of the box such that the cost to build the box is a minimum, right? So we want the answer of W that will cause the cost to be minimum. So because they're asking for W, notice that they're asking for W. It means we have to find a way to get rid of H. And the only way to get rid of H is to make it the subject of the formula using another formula. Remember, two unknowns, two formulas. So this is the cost, which is perimeter. Not perimeter. This is the cost, which is surface area, right? And then we need another formula, which is the volume, because we're dealing with a 3D shape. So let's get the formula for volume. So we know that volume is going to be equals to, what is the volume of a rectangular prism? Remember, it's a prism. Volume of any prism is area of the base times height. So it's going to be length times breadth times height, right? So volume is equals to length times breadth times height. So, right, length times breadth times the height. So let's just write it first just to show them understanding. So length times breadth times the height. Now, what is the length? The length is 3W, right? Then the width is W, the breadth is W. So we're going to have 3W, okay, 3W times W times the height, which should eventually be that H, right? So yeah, times the height. So therefore it's going to be 3W squared H. And we have the answer of volume. That's why, because whenever they know we're going to use two formulas, they always give us the answer of one of them. So the volume has to be 5 meter cubed. So it's going to be 5. So let's make X the subject because we want to end up solving for W. So, by the way, whenever you're solving simultaneously, if you want to end up getting your answer for X first, do not make X the subject of the formula. You're going to end up getting Y first. It's always vice versa. If you want to solve for X first, make Y the subject, then you get X. If you want to solve for Y first, make X the subject, then you get Y. But honestly, that does not really matter, because when it comes to simultaneous equation, you just make whatever is easier to be the subject of the formula. It's just that when you've got a choice, you must know it's vice versa. So notice that because when I solve for W, we have to make H the subject of the formula in one equation so that we can end up solving for W. If you don't make H the subject of the formula and you make W the subject of the formula, you'll end up solving for H first, then you have to substitute again to get W, which is a long cut, right? So here, it's obvious that H is the one that is easy to make the subject of the formula. Besides, we want to make H the subject of the formula so that we can solve for W. So it means that it's going to be, we divide both sides by 3W squared by 3W squared. So therefore, H is going to be equal to 5 over 3W squared. So now we can go back to this formula. So let's just write it underneath here. So we're going to have 90W, then we're going to have yeah, this is what we have. So now in place of H, because H is equal to 5 over 3W squared, we substitute it with 5 over 3W squared, and then it's going to be 90W squared plus, so this will cancel with one of them, and then 4 times 5 is 20, so we're going to have 20 over 3W. Yeah, this is literally what we have. It looks weird, but nothing we can do. So that's the cost. But now they ask for the cost to be minimum, right? I'm sure they asked for that. Yeah, the cost to build the box must be minimum. So let's see what we can do. So we know, okay, fine, before we derive it, we have to make sure it's in a differentiable form. So that's the cost. So let's make it into a differentiable form first before deriving it. So this is going to be, we have to take W up or to the side, which is the same as taking it up, right? So it's going to be 20 over 3. So when you take it up, the sign of the exponent changes. So it's an invisible 1, so it becomes -1. So now we can derive. So now we derive, so we're going to tell them the cost. The minimum cost is going to be 180W. And then this part becomes minus 20 over 3W to the power of -2. So that's what we have. Alright, so now we have to tell them that the cost, right, the first derivative of the cost, let me just do this for fun, the cost on W, right? So the cost on W, because it's written in terms of W, must be equal to 0. So therefore, but anyways, let's just leave it like that since I have already named it everywhere. So it means it's going to be 0 is equals to 180W, come on, let's just fix it, so 180W. Then 20 over 3W to the power of -2. So we have got 2 of them here. So whenever we're solving for X, I prefer taking it back down. So let's take it back down. So so that it can be 20 over 3W to the power of 2, right? So because this moved from numerator to denominator, we have to change the sign of the exponent. So how do we get rid of the denominator? By multiplying everything by the LCD, which is 3W. So 0 times 3W is 0. Then 180 times 3W squared, it's going to be, let me just see something, 8, 16, 24. It's going to be 54, 540, right? 540W cube. And then the nice thing is that it's going to cancel here. So we're going to have 20 over 3 just. Yeah, so now we take this to the other side, so it becomes 20 over 3 is equals to 540 W cubed. So now we divide both sides by 540, and in the calculator you must type 20 over 3 divided by 540, right? Don't type divided by 540 in the calculator like this, because you might make a mistake and get it wrong. So I know the answer is going to be okay, it's going to be 150 plus 150 plus, okay, fine, 1.5 rather, plus 120, right? So it's going to be 1620. So it's going to be 20 over 1620. Okay, so this is equals to W cubed. So they asked for the width such that their cost will be minimum. They knew what they were doing. So I don't think I have to get the full answer, right? Okay, so for now, just notice that this cancels this, and then it means we're going to have 1 over, so 162 divided by 2, it's going to be 100 divided by 2 is 50, 60 divided by 2 is 30, and then, so we're going to have 81. Oh, okay, fine. Is it really 81? Alright, it would have been a perfect answer if it was something like, if it was the fourth power or the squared power. Yeah, so this is not a perfect cube, but the answer is just going to be the cube root of that, right? So the answer is the cube root of 1 over 81. Yeah, 1 over 81. So that's the cube root, or we can even write it as 1 over the cube root of 81. Okay, let's just get this into the simplest set form. So I know it's 27 times 3. So it means it's going to be 3 root 3. 3, not 3 root 3, but 3 cube root 3. It's going to be weird. So 3 cube root 3. But whatever form the calculator gives, you can write it. You can even write it and just put it into 2 decimal places. Yeah, but anyways, that is the width, just the answer of that.